In this video, we will learn different types of vector norms with example and how to sketch their graph. A norm is a function from a vector space V to the set of non-negative real numbers that satisfies the following three properties. To understand this property, let's consider the Euclidean norm, which is the distance of a vector x1, x2 from the origin. First property says that if the vector is non-zero, then the distance of that vector from origin will be more than 0. And if the vector is 0, then the distance of that vector from origin will also be 0. 0 vector means all its component is 0. Second property is the scaling property. That means we are scaling the distance by the factor lambda. Third property is called the triangle property. That is, if you go this way, then this distance will be less than the distance of this path plus this path. Types of norms. For an n-tuple vector x, the LP norm is defined as this way when p is in this interval. And the LP norm is defined this way when p is infinity. If p equals to 1, then we get the L1 norm. That is, we will take absolute value of each component and then add them together. If p equals to 2, then we will get L2 norm. That is, we will first square each component and then add them together and finally take its square root. L2 norm, also known as Euclidean norm. If p equals to infinity, then we get L infinity norm. That is, we will take absolute value of each component and then take the maximum component from them. For example, the vectors x, y and z are given. We need to calculate L1, L2 and L infinity norm. So for L1 norm, we take absolute value of each component and then add them together. We got 4. We also take absolute value of each component and add them together. We got 12. Similarly, we got 10 for z. For L2 norm, we take square of each component and then add them together and finally take the square root. We got the answer as 2 square root of 2. Similarly, for vector y, we got 4 square root of 3 and for vector z, we got 5 square root of 2. To find the L infinity norm, first we take absolute value of each component, then take its maximum. So maximum of 2, 2 and 0 is 2. Similarly, for vector y, we take absolute value of each component and take its maximum. We got 4. Sketching different types of norms. Suppose the vector x has two components, x1 and x2. And let that x1 varies from -1 to +1 and x2 also varies from -1 to +1. We also assume that the L1, L2 and L infinity norm of the vector x is 1. Now, L1 norm of x is absolute value of x1 plus absolute value of x2. And this one value is 1. And if we write without absolute sign, then we got plus minus x1 and plus minus x2. If we consider the plus sign, then we got this equation. And if we consider the minus sign here, we got this equation. If we consider plus sign here, then we got this equation. And if we consider minus sign here, then we got this one. Similarly, we got this one and that one. Now we have total 4 equations, and if we sketch the graph of each of them, then we will get this graph, where this one is first one, This one is third one. Similarly, the other two. L2 norm of x is square root of x1 square plus x2 square, and this one value is 1. So we got this equation, and after squaring on both sides we got this equation. This is equation of a circle center at 0, 0 and radius 1. Now to draw the L infinity norm, we take maximum of x1 and x2. When x1 is 1 and x2 varies from -1 to +1, then we got this equation. So for this straight line, x1 is 1 and x2 varies from -1 to +1. For this line, x1 is -1 and x2 varies from -1 to +1. Similarly, for this straight line, x2 is +1 and x1 varies from -1 to +1. Now, if we sketch all of the norms together, then we will get this graph, where this one is the L1 norm, this one is the L2 norm, and that one is L infinity norm. Now, to compare the norms, let x1, x2 is -0.6, 0.8. We just take a points here. Now, if we calculate the x1 norm, we got 1.4. If we calculate the x2 norm, we got 1. And if we calculate the x infinity norm for this vector, we got 0.8. Now, if you compare all of their values, you will see that L1 norm is bigger than L2 norm, which is bigger than L infinity norm. This relation. Thanks for watching.